We have an embedded systems and application laboratory here for a SwitchLEDinterface. We have notes in the description below the like button. Section goes over this. But in preparation, we're going to need a launch pad, a switch, 10 kilo ohm resistor, an LED, and 470 ohm resistor, just one of each. So we have our starter project, which we're going to look at in a second. It's inside of here. Going back to kind of the rubric, we have our system requirements. So in this lab, we will build a switch interface and it implements positive logic. We're going to build an LED interface that implements positive logic. We're going to attach the switch and LED to a breadboard and interface them with our TM4C123. Overall functionality of the system is similar to our Lab 6 with 5 changes. The pin at which we connect is going to be moved to PE0. We will have to remove the PUR initialization because pull-up is no longer needed. So if we go into Lab 6, if we want to reuse some of our knowledge from there, we can just remove this. The pin to which we connect the LED is going to be PE1. The switch is changed from negative to positive logic. Positive logic means when the switch is pushed, the electricity or current, whatever, flows through it. Negative logic is when it's not pressed, there's going to be something flowing through it. We should decrease the delay so it flashes about 5 Hz. If the switch is pressed, we turn on the LED for 100 milliseconds, turn off for 100 milliseconds, and then repeat, so it's going to be toggling. So our steps here are to make PE1 an output and make PE0 an input. The system starts with the LED on. We wait 100 milliseconds. If the switch is pressed, then toggle the LED once, else turn the LED on. So steps 3 and 4, we're just going to repeat it, checking to see if the switch is pressed or not. Now we have our debug in our simulation. We should draw a circuit diagram. It looks something like this. So this is more for like the real breadboard. We have a switch here. We have a power supply of 3.3 volts. It's going into the switch. We have into switch 4 or 3, and then it comes out of 1 or 2. And then from here, it's going to go to our PE0. Now our PE1 is going to output to our LED. It's going to be red for this, so we'll remember this when we do our code. We're going to connect PD3 here. That way we can see what the output is, and then we have our resistor of 470 here, and then we're going to ground both of these. We're going to come back to this when we build this on our breadboard. So that's one possible way to do it. The lab describes PE0 for input and PE1 for output, but tables 6.1 and 6.2 show the options that automatic grader can handle. So we could connect the output to PA3, 1, or PE1, and we can connect the input to these different things. So different ways we can connect them, but we're going to use the one they told us originally. We're going to write software that satisfies the requirements for this lab. The best approach to time delay will be with a hardware timer. We learned about that in Lab 7. I don't think we've learned about that yet, if we've been following along with the labs in the playlist. In this lab, however, we do not expect a hardware timer, so we're going to be using like the one in software. Now, we're going to look at debugging in our lab, and we'll come back to do it on the real board. So in our lab, the first thing that we have to do is include this. Now, this was not included in the actual project that we have here. I brought this in from the Jonathan Valvano videos that all these labs are kind of based off of, or at least he bases his videos off of this. So this is gotten from there, all these different ports. We have our data R. This is very important because this is very similar to like a Lab 6, like it said, except we're changing our port to be port E. So all of these are now E. We have our global declaration sections. Of course, we have to initialize a switch 1 because we're going to be pressing down. We have void disable interrupts and enable interrupts. These are for our graders. We have our delay and then our port E in it, so we can initialize like our clock and everything. So pretty simple from here. We have our subroutine sections. So PE0, PB0, or PA0 connected to positive logic momentarily. Switch using the 10k ohm pull down resistor, PE1, PB1, or PA3 is connected to positive logic with an LED through 470 current limiting resistor. That's basically just telling us what this was right here. To avoid damaging our hardware, ensure that the circuit's mapped to schematic, and that's going to be okay. So we have our int main void here. The following version tests input and output. So we have our TExaS init right here. It's going to test for our switch 1, PE0, and our LED pin, PE1. So this is the activate the grader. We have our port E init. If we scroll down a little bit, our port E init is going to be this right here, where we basically have everything that's set. So our delay is like this, we have our port E clock, and this was also retrieved from his videos. Now, the only thing that's different is that in his videos, they had values for this, but since there's no alternative, no analog, everything should be 0. Then we want to enable PE1 and PE0, so these are going to be like this. Now if we scroll down, we can see the LED colors. We want to use red, so we're going to use 0x02, so we'll keep that in mind. Scroll back up here. This is our time delay. We've gone over this previously in other labs. Back inside of here, we have this switch 1. So I believe this starts with like our LED on, and then we're going to check if the switch is pressed or not. If it's pressed, we delay 100 milliseconds, we do this. We set our GPI port E to be red. We come back here, it's red. We can see that and now if switch 1 is still pressed, we'll fall into the if statement, delay again, and then just keep toggling over and over. Otherwise, we're going to be inside of here, and we're going to set it to be like this, so it's just going to be on. Otherwise, we're going to toggle it. So this would go from like a 1 to a 0, and then 1 to 0, and 1 to 0, and basically off and on. So that's how the software side of this would work. We can go into our options, debug, use simulator. We can go into build our project. We can debug our project. Clicking OK in here. We want our port to be PE0 because that's what we have testing in here. And then our output is going to be PE1. So we can grade this and we can check all the different things that it's grading. If we wanted to actually monitor a switch, we could right click the switch, add switch 1 to our watch 1. So we can watch that there. This switch 1 is the same switch 1. We can see that we've just added in there. I've added this one. We can add our watch here, and then we could also add our watch here. So I'm kind of adding in order so that we could possibly view some stuff. I think we can also look at a logic analyzer. So if we click this part right here, we can see when the LED is toggling on and off and everything. So if I pull this down, make some room, click grade, and it's grading from here. We can see that it's off, and then when this is pressed, the switch is going to toggle, and then when it's off, the LED is on. So 1 and 0 is high and low. Right now, the input is low, so the LED is high. When the input is high, the LED is going to toggle, just like it does here, and we can see that these values are changing. And then it goes back to 2. So if we do it again, let's look at the value change for our different ports. We see that they change from 3 to 1. Now, I didn't have to duplicate this because it really just adds the exact part. It really just adds the part itself, and it doesn't differ between whatever we add in. So we just need to add it in once. But basically we saw it go from 0 to, so it being red, to like 3, and it's still red, it's just adding this and this together. So that's all it's doing, because what's going to end up happening is it's going to look like this. So this is a 1 plus 2, and that's going to give it a 3. And that's happening whenever it's toggling. It goes from 3 to 1, 3 to 1, 3 to 1, 3 to 1. And this is because inside of here, we toggle this as 2. It's going to go through here. It's a 1 right here, so it adds them together and it brings it up. So that is how the simulation would work. Now we're going to look at the real board. So we're going to build this on the real board. Now if we scroll down, we can see just some parts of it. So it's going to tell us what happens. After the software has been debugged in our simulator, we're going to want to build the hardware on the real board. So to build the circuits, we'll use a solderless breadboard, also referenced as a proto board. The holes in the proto board, and it just tells us how the proto board works, or the breadboard, and then more about telling how the breadboard works. This is the important part. To make connections on the TM4C123, we can run male to male solid wire from the bottom of the microcontroller to the proto board, and I'll go over that in a second. For example, assume we want to connect this to the positive side, we just use a solid wire and connect this. It's not going to look like this. This seems to be like a little different of a lab. Ours is going to be a little bit simpler, just getting familiar with everything. We have some information on a switch. So we can notice the switch has 4 pins and it's in a rectangular shape, shown like this. Each button is a single pole, single throw, normally open switch. Normally open means that when the switch is not pressed, it's just open. Normally closed is if the switch was not pressed, it would be closed. So that'd be like negative logic. All 4 pins are connected to the switch. Pins 1 and 2 are connected inside the switch. So are 3 and 4. The switch itself is positioned between pins 1 and 2 and 3 and 4. So if we connect something at 3 or 4 and then we close this by pressing the button down, it'll go through 2 or 1. Remember not to remove or replace wires when the power is on. That could be bad. We could short circuit something. The next step is to build an LED output circuit. Using our datasheet, we can hold an LED and identify which pin is the anode and which is the cathode. LEDs emit light. This is just going over the LEDs. We have our anode, which is the long side, cathode is the short side, or the side that has kind of a flat side where the rest of it is round. This is the way an anode and a cathode is drawn when we're doing circuit schematics. We go in depth about which resistors we're using, and this is what our board is going to look like. We'll come back to this. Part D is how we would debug. So we want to debug our combined hardware and software using the board. First, we will use the debugger to observe the input pin to verify the proper operation of the switch interface. So we'll have to single step through the code to initialize all of our ports and then execute the peripherals system view GPIO command. As single step, we should see the actual input as controlled by the switch we have interfaced. So first we're going to do that, and then we are going to also use our PD3. But we'll actually do it all at the same time because it's very simple. So we're going to debug the output and the LED. PD3 is a debug probe. We're going to use it to measure any voltage between 0 and 3. With the power off, we're going to connect the wire between PD3 and the LED cathode, which is also connected to the end of our 470 resistor. Again, we'll build this in a second. This connection is illustrated as the blue wire in our figure, this one right here. We want to define VPD3 as the voltage on PD3. We're going to power it up, start the debugger, and run our program, but don't press the switch. The LED should be on. We're going to verify all of our aspects by going from peripherals, system view, GPIO, and then port E in our debugger. And then we have some more information about this right here. So let's actually build this using this little schematic we have right here. So for this right here, for simulation, we're going to have to close it. We're going to want to go into our debug. We're going to use the Celeris ID CI. Click OK. We don't need to build the project yet because first we need to actually build it on our breadboard. So right here I have my board and everything. Notice how it's unplugged. So now we're going to be putting all of this in. I already built this just to kind of demonstrate everything, but we're going to show how everything works. The first thing is that we're going to need a ground wire. So if you look at your board, this is the back of the board. On this black part right here, it'll have something that says like GND, and that means ground. So we represent this usually with a black wire. I'm going to take this black wire, I'm going to plug it inside of here, and then I'm going to plug it into one of these power rails. The power rails go all the way down, so whichever one you choose, typically I will use the negative for ground. So the -1 is grounded. Now I'll have a picture of our circuit diagram that we're going to have to build on the screen, and we're going to follow along with that. So we know we have two resistors going to ground. We have a 10K and the 470 ohm resistor. So you want to verify which is which. For me, this is the 10K resistor, and this is the 470 ohm resistor. So with that knowledge, we can build this. Again, this is ground. These are our two resistors. So what else is next? Well, if we keep going up from here, the next thing is our LED. Now remember, in the circuit diagram, the plus is on the top, so that means it's the anode. It's where the current flows into. So when we look at this LED, we're going to want the longer side to be on the top part. I kind of like to try to build my breadboard with the circuit diagram, that way we can really see what's going on. So we have the anode, we have the cathode right here. We know that the anode is going to go on top, so I'm going to put it on this side of the breadboard, up here, and then I'm going to put the cathode on the other side. So anode on this top part, and the cathode on this side, that way they're not on the same column. And so that is also in the same column as our resistor, and that's in the same thing as this. That's important because we need whatever current flowing through this wire going into the LED to eventually go into ground. So that is how that would work. Now this wire is the wire to test our voltage. This is going to go into the PE3 of our board, fourth one from the bottom. So inside of the fourth one, we're going to plug it right here. And this is just to monitor the voltage coming out of our LED. We could also plug it in before it and monitor the voltage going in, but we're not going to do that here. So we're going to just put it right here. Now, what is this one? Well, this represents our input. So the current is going to go from here, here, into our LED. Well, how do we get this input? Well, we get it from this switch. Now we look at our switch. So how do we wire the rest of our switch? Well, we know that one side is going to be connected to PE0, which is in parallel with our ground. So our ground's right here. That way we plug in this yellow wire to our PE0. It's going to be right here, third on the left-hand side of our board. So that is going to plug right there at this node. We are going to have our switch. It's going to plug into number 2, which is this one. And then we can have number 4 up here. And then we are going to plug in a 3.3 volt power supply. The 3.3 volts is up here. So we have this 3.3 volts on the right hand side, the far right hand side. It's going to go into this top rail for power, and then this wire is going to go to the switch. So this is always getting 3.3 volts of power. Now we can allow this power to go through our switch. Some of it is going to go down to ground because of this resistor, some is going to go into the board. And then that is going to output to our LED. That's how the LED stays lit when the switch is not pressed. And then when we press the switch like this, it's going to flash, it's going to toggle by allowing it through, and then it's just going to go into our switch. Doing nothing like this allows some current to go through here, and then pressing it is going to allow it to toggle. So that is how that would work, building it with the schematic and everything and going along with our code. Now what we can do is plug it in, and then I'm going to turn the board around, and we want to turn it on. So we're going to flip this on switch. That green light should go on, and my red light is on because I've already done this project. But now we are going to go into the debug in the computer. But if you don't have that configured, that's okay. We're going to go into project on the computer. We can build our project. We're going to want to load this on the board, so we can click load. We're going to go into debug now, so we can click our debug. Once we're in debug, click OK. We're going to be inside of here. We have our logic analyzer to see what's going on. We have everything inside of here that we want to look at. So now we can start this out. We can start running it. So the first thing that we're going to want to do, just to run it on the board, is we can press the reset button, which is right here. So pressing the reset button, the LED turns on. Now we can play with it. We can see if it works on the hardware. It's on. Pressing the switch and holding it down, it's going to flash. You can see it flash just like that. So it looks like that works. Now for some reason it kicked me out of the debug. I'm going to go to clean targets, build project, then I'll load this onto my board. For some reason it's giving me a connection failed, so let's actually turn this off, and then we could turn it back on. Trying to clean the target and building the project now. We'll go to load. It looks like it loaded it correctly, making sure that we are in the simulator. And then we're going to go into debug from here. We're in the debug mode, and now before we touch anything on our board, let's step through this. So stepping through this, we can use this up here. So we're going to step. Nothing happens. We can see we have our R0, our R1, and our R2. We can notice that those change. We're going to step through again. Seems like everything is just initializing. Now I think there is some kind of weird thing with it not being on. So I'm going to press the reset button. Pressing the reset button, the LED turns on. Now we can try to run this. I'm going to try to use the run. Nothing's happening, so I'll exit out of here. And let's try to step through it. Now that broke it again, so let's go back into our debug. Okay, so whatever I did, I have now gotten it to work inside of here. I think it just had to initialize a lot of things, but now we're inside of here. So I'm going to start off by going back to our while loop. We can see I'm not pressing anything. We're in our while loop right now. If I don't press anything, we're of course going to go into the while loop. We're going to start with this like this, and then we're going to go into our if-else statement. We're going to check our if. It's false, so we're going to go to our else statement, and we're going to output a red. Now what happens if I press the switch? So I'm going to press and hold the switch. Nothing's happening on our board, but that's because we are inside of our code right here stepping through it. So we're going to step through this. Again, we're not running our code, we're stepping through it. we're at the top of our while loop. I'm pressing down on the switch. We're going inside of here. We're going to check our if statement. Our if statement is going to be true. Notice how our R0 is just 1, our R1 is 02. So we're going to go inside of here. We're going to want to step over the delay 100 milliseconds. So I'm going to step into it. We're inside of our if statement now. Step over, because if we don't step over it, we're going to go inside of the actual function. So this next one, we're stepping over it. And then we're going to step through. We can see it turns off. That's simulating its flash. And then we're going to step in again. I'm still holding it. So we're going to step in again. The delay, stepping over. We're going to be here. And then stepping over, we are lit again. If I let go of the switch, we're going to run through it. Stepping through, we're going to fall into our else statement. Now one more time, pressing and holding the switch down in our while loop. We have this here. We're going to go into our if statement. We're going to delay 100 milliseconds after we step over. So we stepped over, and then we are going to have this port E step. We can see our LED is turned off. Now if we go through again, step, step, step in, and then step over, and then we're going to step, and then our LED should turn back on. So that's going to be basically it on how the code runs, and that's it for this demo and for this lab.